Hi everyone. Here is the first class for indices. We want to discuss some laws of indices. First of all, many students, especially beginners, used to say the first law of indices, the second law. If they have like a conversation with another student, they will say, we have like the fifth law. Oh, no, that one is the sixth law. No, we don't have them in order. So it's not necessary for the teacher to write first law, second law. No. We don't have them in order. Rather, we say the product law or the multiplication law, the quotient law or the division law, and so on. Now, let us start with the product law. The product law or multiplication law. What does it say? If we are multiplying two numbers, let's say a to the power m, a to the power n, this with a power, this with a power, but the bases are the same and they are multiplied. The product or the multiplication law says of the basis we take 1 because they are already the same. So what happens to the power? We add the power. There are two questions we need to answer here. Why do we take one base? Because they are the same. Why do we add the powers? Because multiplication. We don't add the powers because of the same base. We add the powers because of what? Multiplication. Yes, we don't take one base because of multiplication. We take one base because of the bases are the same. So let's know this one. So for example, if the teacher says 2 to the power 3 times 2 to the power 2, simply the bases are the same. We take 1. What happens? Because of multiplication, we add the powers 3 plus 2. So this will give us 2 to the power 5. 2 to the power 5 is same as 2 times 2 times 2 times 2 times 2. And that will give us 32. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So if we have p to the power 3 times p to the power 4, the bases are the same. We take 1. Because of multiplication, we add the powers 3 plus 4. So this will give us p to the power 7. But this is not a known value, so we cannot simplify it further. This is what we have. So this is the product law. The second one, let's talk about the quotient law, or we can also call it division law. Just so similar as compared to this. If we have a to the power m like this, divide by a to the power n, because the bases are the same, we take 1 just like we did here. We take 1. Because of division, we subtract the powers m minus n. It is a must to say this minus this and not the other way around. So what if we have a to the power 4 divided by a to the power 3? Well, the bases are the same. We take 1. Because of division, we subtract 4 minus 3. So this will give us a to the power 1. When the value has a power of 1, we neglect the power. We ignore it. So this is a. What if we have like 3 to the power 2? Or let me make it simple a bit. 3 to the power 2 like this. The bases are the same. What happens? We take 1. Division, what do? We subtract. So 3 to the power 5 minus 2 is 3. So we have 3 to the power 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3, 27. So 3 to the power 3 is what? Is 27. So this is the quotient law. This is the division law. Now let's see another. If you want to copy, then you can pause the video, then you copy. The third one is the power or index law. The power or index or exponent. exponent law. Power, index, exponent, they are the same. The plural for exponent, just add s, exponents. The plural for power, just add s, powers. The plural for index, remove the ex, then you add ICES, indices. Okay. Now let's talk about the index, the power, the exponent law. It says, when a value has a power and there is another power outside, well, we can simply say a base has two or more powers. It is possible that we have another outside like this. It's also possible. So when a base has two or more powers, what happens? We take the base, then we multiply the powers. So m times n times p. M, n, p. But since we are multiplying, you can call it PNM, NMP, NPM, no problem, just the same. So a to the power m to the power n. This base has two powers, one inside, another outside. What happens? We take the base, then we multiply the powers, m, n. We don't add the powers. What if we have 3 to the power 2 to the power 3 here? The base has two powers, one inside, another outside. We take the base. What happens to the powers? We multiply them. 2 times 3. So this gives 3 to the power 6. So 3 to the power 6 will give you, you can use your calculator and tell what you have. 3 times 3 is what? It's 9. 9 times 3, 27. We have 6. 3 times 3 is 9. 9 times 3, 27. 3 times 3 is 9. 9 times 3, 27. 27 times 27 will give you what we have. The calculator will give you that. Okay. So what next is, we are done with this one, this one, this one. We'll go to negative power law. Negative power law. Negative power law. So with negative power law, I want to use this to explain. Okay, yeah. This one is similar to number 7, so I will explain this too. Yeah, negative power law in general perspective. Here, fractional base and negative power. Okay, now let me give you two scenarios here, one for this and one for this one. A to the power minus 1. A over B to the power minus 1. Whenever the power, okay, let me give another. A to the minus 2. A over B to the power minus 2. Whenever the power is negative, the first thing you do is to ask yourself, what is the inverse of what? Of the base. The base here is A. The inverse of A is 1 over A. Remember, when a value stands alone without a denominator, it's like there is a denominator of 1. So this one, as it stands, even when you don't see it, there is a denominator of 1. Just that in mathematics, we ignore denominators of 1. But there are cases wherein we need to recognize them, like in this case. A is the base. What is the inverse of A? Is 1 over A. So whenever the power is negative, ask yourself this question. What is the inverse of A? The inverse of A is 1 over A. So what do? This is what we have. But it's supposed to be raised to the power 1. But once we say 1, we forget about the minus. It's because of this minus we consider the inverse of the base. But because the power is 1, we don't necessarily write it, so we leave it like this. We come to this one again, the one I was trying to talk about here, fractional base and negative power. Here, the power is also negative as here. We ask ourselves the inverse of A, which is 1 over A. The same thing goes. What is the inverse of A over B? Is B over A, then raised to power 1. Once you consider the inverse of this, you swap it, forget about the minus. So automatically the power becomes positive. But because the power of 1, we usually ignore it, then this is what we have. Now let's come to this again. The power is negative. The first thing that should come to your mind is, what is the inverse of A? The inverse of A is 1 over A. What is the power 1 or 2? The power is not 1. So we say raised to power 2. I know you are considering why we are not writing the minus again. It's because of the dismissal of the minus. The reason we swap what? This A. Instead of A, now the inverse of A. So therefore, 1 raised to the power 2 is 1. A raised to the power 2 is A squared. I hope it is clear. We come to this again. The power is negative. Once the power is negative, what do? We consider the inverse. So B over A. So what do? We ignore the minus. We have only 2. If this one affects B, we say B squared. If it affects A, we say A squared. So this is the power law. Let's see if we have numbers. Don't forget, if you want to copy, pause the video, then you can copy. What if we have like 2 over 3 raised to negative 4? What do? The power is a minus. The power is negative. So what is the inverse of 2 over 3? It's 3 over 2. Automatically forget about the minus. Write the positive power. So when the power affects 3, we say 3 to the power 4. When the power affects 2, 2 to the power 4. So 3 to the power 4 is what? It's 81. 2 to the power 4 is what? It's 16. I hope that one is clear. So I've explained number 4 and number 7. Do not forget, if you want to copy, pause the video, then you can copy. So now we go to number 5. Number 5 is talking about fractional power. 5 is talking about what? Fractional power, fractional exponent, fractional index. Okay, now the power is a fraction. The power is a fraction. It's a fraction. So this is what we are talking about. Okay. Whenever the power is a fraction, the first thing you do is to write the roots. Whenever the power is a fraction, write a root. That is the first thing we do. The power is a fraction, write the roots. The power is a fraction, write the roots. So what else do we do after we've written down the roots? The base goes inside. The base is inside. Whether it's a fractional number, value, or not a fractional value, the base goes inside. What else do we do? If the denominator is 2, it becomes a square root. When we say square root, we don't write anything here. If the denominator is 3, it is a must to write it. No longer a square root, but what? Cube root. The denominator is 3, we have cube root. The denominator is 4, we have fourth root. Do not write it like this. It has to be inside. I hope that one is clear. So the base is inside. 2 is supposed to be here, but because of 2, we don't write it. That 2 we used to say x squared. Here the word square is the reason we call it square root. So meaningfully there is already 2 here, but we don't write it. Just like when there was already an agreement that when the power is supposed to be 1, we don't write it. So that was the same agreement, similar agreement that if here is supposed to be 2, we don't write it. That one is well understood worldwide, globally. So if the power, the denominator here is 3, it's a must. The denominator is 4, is a must, or even more is a must. What if we have x to the power 1 over n? Don't get confused that the power, I don't see a number, I'm now seeing a letter. Just go with the concept that once the power is a fraction, you have your roots. The base goes in here. The denominator of the power is here, nth root. This one is pronounced as nth root, nth root. I hope it is understood. Now, the power is a fraction, the base is inside, the denominator is supposed to be here, but because of 2, we forget about it. If it is 1, we don't do anything further. The base is inside, the denominator is 3. It is here, the numerator is 1, we don't do anything further. The base is inside, the denominator is 4, it is here, the numerator is 1, we don't do anything further. But what if we have like a to the power 2 over 3? Yeah, numerator 1, 1, 1. But here is now 2. The first thing you do is, the fact that the power is a fraction, we have our roots. That is the first thing you do. The base is a, is inside. Yeah. The denominator is 3. It is a must. The power is what? Sorry, the numerator is 2. Everything is raised to the power 2. But because of the numerator is 1, we did not do anything else. 1, nothing else we did. Here, nothing else we did. But here, the numerator is 2. We have to see everything raised to the power 2. Now, again, the power is a fraction. We have our roots. The base is inside. The denominator is supposed to be here, but it's 2. We forget about it. The power is a fraction, the roots. The base is inside. The denominator is 2. We're supposed to write it here, but we don't do it. The numerator is 1. We don't do anything further. But we don't stop here because 9 is a perfect square, of which its square root is 3. I hope it is clear. For whatsoever you want to take down, just pause the video, then you can write it down. Again, let me change this to this so that I will explain something better. The power is a fraction. What do? We have our roots. The base is 27. The denominator is 3. The power is not, so the numerator is not 1, it is 2. So everything raised to power 2. We don't stop here because 27 is a perfect cube. Yeah. So a perfect cube number. What is the cube root of 27? It's 3. The cube root of 27 is 3. But don't forget that there is a power of 2. So this is 3 times 3. 3 to the power 2 is 3 times 3, which is what? 9. So this one will give us 9. Okay. So we are done with positive ones. Now, what if this law extends to the point that the power is negative? Let me also make it more meaningful like this. You see, just follow what the principle is saying. The power is a fraction. You have your root. The base is 8, is inside. The denominator, oh, sorry. The power is a fraction actually, but it is negative now. It is what? It is negative. So we consult what we did here, negative power, or fractional base and negative power. So once the power is a fraction, the power is negative, what do? If you can recall again, we consider the inverse of 8. What is the inverse of 8? It's 1 over 8. So now raised to 2 over 3. Do we need the minus again? No. We dismiss the minus. Why do we dismiss the minus? Because we've considered the inverse of it. Now, where are we now? We are in the fractional power. If the power is a fraction, we have our root. The base is inside. Do not write it like this, then you make it like this. It is outside. This is wrong, please. The power is a fraction, we have our roots. The base is inside. The base is a fractional base now. It's inside. The denominator here is 3. The numerator is 2. It is now our power. One thing about 1 is a perfect number in such a way that the 4th root of 1 is 1. The 10th root of 1 is 1. Any number you can think of, even if you say the 26th root of 1 is 1. Likewise, 1 raised to any value is 1. Okay, so the cube root of 1 is 1. The cube root of 8 is 2. Why the cube root of 8 is 2? Because 2 times 2 times 2 will give us 8. There is a power of 2. 1 squared is 1. 2 squared is 4. So this is what? The negative fractional power. So we are done with this. We are done with this. Okay, I think the last one, of course, is the one students enjoy the most. It is the one students enjoy the most. Just tell the student that whatsoever that is raised to power 0 is 1. Whether it is 2 raised to power 0 is 1. 3x over 4 raised to power 0 is 1. Whatsoever that is compounded, you have the root of 3x minus 1 over 4 raised to power 0 is 1. Absolutely. So that one is so easy. Thank you for watching. Do not forget to follow, like, share, and comment. See my next video.